next video, we're going to take a look at the finding t statistics rather than z statistics. The t statistic, the calculator for the t, is very much like the normal. It looks a lot like it, except it changes depending on the size of the sample. Now, for most cases, and you'll learn when degrees of freedom is different, but degrees of freedom is usually one less than the number of elements in the sample, the number of values in the sample. So if our degrees of freedom is 10 and I want to find the probability of x being less than 0, this is my t statistic, okay? So let's say that I want to find the area, if my degrees of freedom is 10, let's say my degrees of freedom is 5. Notice when I compute how this changes. So it's still 50% less than 0. But what if I put in something like a negative 1.46 and I compute that? If I change the degrees of freedom to 10, if I change the degrees of freedom to 30, you notice that the percentage changes because the graph changes. Okay, a smaller degrees of freedom, like 5, creates a very steep, a lot elongated problem here, where if I have like 100 for degrees or 99 for the degrees of freedom, because my sample size is 100, look how much more it looks like a normal curve. Okay, so I can find the value less, just like I did with the normal, less than or greater than a particular value. Now remember, this is the t. This is the t statistic. So what if I have the area in the right tail is 0.05? I want to find the point, the t value. Here I was putting in the t value and finding the area. What if I know the area? So if I know the area to the right is 0.05, and I know that I'm looking for less than, and I know that my degrees of freedom is 6, and now I compute. I need to do this back again. Put the degrees of freedom first, and then put in 0.05. This tells me that the t value, or the t statistic, is a negative 1.94. Now there is also a table that you can use to look these things up, but this is just another way of, you could use the t calculator as well as in place of the normal calculator when you have small samples. Thank you.